My name is Dave Fisher, and I'm glad to have a mic today because I'm getting over a cold, so excuse the voice here. Normally I wouldn't need a mic, although it sounds like we're doing some recording here, so it's good to have that. But in any case, I am a solutions architect with Veracode. And Veracode essentially is a cloud-based platform that will scan your software as you're building it and help you to uncover weaknesses and help you fix those weaknesses. Okay, so the topic for this particular session is going to be Veracode Fix, and we'll explain what Fix is and why it's needed and kind of how it works. So really kind of the first thing we're going to identify is the problem. What is the problem we're solving with Veracode Fix? So really here, the challenge is being able to kind of whittle down and decrease your security debt over time. You can see that security debt is a real problem. Most organizations have security debt. A lot of them have critical security debt, which is even more serious. You want to make sure that you're prioritizing and you're able to really reduce that debt and address it over time. And this is really just Veracode. This is where we're getting the stats from, but if you think about the industry as a whole, not everyone is working with a sort of enterprise class platform. So, there's probably a lot more out there that needs to be addressed. And really the challenge a lot of times is not just finding the flaws, but fixing them. And for a long time, Veracode has had contextual remediation advice and guidance in our solution that tells you, generally speaking, how you might go about fixing a given weakness in your code. But AI has kind of taken us to the next level here, and that's what we're going to talk about during this session. All right, so the reality is most folks nowadays are using AI coding tools. Sometimes they're sanctioned, sometimes they're not. I think that's important, is that it's being done either way. And you've got, just as examples, you've got GitHub Copilot, Amazon Q, ChatGPT, and a number of other ones out there. And they're making the developers' lives easier. There's a reason that they're using these AI-based tools. And so that ship has really sailed in terms of, if you're trying to restrict developers, it's going to be very difficult to do that for AI assistance. And really anyone can see why. It's because if you look at some of the numbers here, code can be generated 35 to 45% faster if you're using one of these generative AI tools. And just kind of firsthand experience, I was doing another demo in partnership with Amazon, and I downloaded Amazon Q and got into my IDE. I was able to generate applications just like that. I'm sure the same is true with Copilot. You can even ask it to analyze your code base. You can ask it questions about the code. You can ask it, if I want to do this, if I want to achieve this goal, what's the best way to do that? Can you please generate the code for me? Why isn't this working? Right? At one point, I had to go and download Node in order to run this JavaScript app. I mean, it's going to walk you through everything. It's amazing how much productivity can be gained. But what's happening then is that it is helping developers to become more productive, which is wonderful. But the question is, will the code be good code or bad code? What kind of code is coming out of these generative AI tools? So it turns out that about 40%, roughly, of the code that comes out of Copilot contains known security vulnerabilities. And that's kind of a little bit scary. And ultimately, the kind of quality of the code that is going to be generated by one of these tools is roughly equivalent to the quality of the code that humans generate in general, because they were basically trained on a number of open source repos that humans built, right? And those repos themselves, many of them have vulnerabilities in them, unfortunately. So kind of what we end up doing here is we've got kind of the remediated flaws line is kind of going to stay normal here. There's nothing aside from some of the newer tools like AI-based tools. There's really nothing that's going to allow you to accelerate the fixing of these flaws. Kind of if you're relying on traditional means, you're really going to just be kind of looking at some advice. Maybe you're Googling how to fix something. It takes a lot of time to figure out how to come up with a fix for a given code flaw in your application. Now the discovered flaws, you can see that going up here, up and to the right. The reason for that is that we're now creating a lot more code. We're creating it faster, creating it more efficiently. The problem is that that code is not necessarily secure. And so we're discovering more and more flaws, and so the level of security debt and the security gap is growing here, almost exponentially here as AI tools are becoming part of the mainstream, and they're being used. Some folks call them Turing bots, different ways of describing them, but any sort of code generation assistant is going to end up generating, obviously, more code and creating more functionality. But again, you have to assess the security vulnerabilities in that as well. So that's kind of what we're talking about here is AI-based security remediation. Basically, there are a lot of AI-powered security tools out there, and quite a few of them have kind of sprouted up quickly. We're kind of explain how Veracode's take on an approach to AI security is unique. So one of the most important aspects of AI security remediation would be ensuring that the system is trustworthy. We want to make sure that there aren't hallucinations. Unfortunately, some folks have tried to take the existing tools that are out there that have been, again, trained on code in the wild, open source repos, code that unfortunately has known vulnerabilities, and they try to retrofit those, and a lot of times the solutions that come out, these security solutions, have hallucinations in them, and so that can be a challenge in general. You want to make sure that, the other thing too is if there are, unverified solutions from the data set, there are all sorts of potential problems with model poisoning or prompt injection. You need to make sure that the solutions are consistent and correct when you're talking about the models themselves and how they're trained, what type of data they're trained on. So with Veracode, we're using curated data and supervised learning. We'll talk a little bit more about that in a minute, but I think it's an important sort of difference here in terms of how we approach this problem. And the next thing is easy. You want to make sure that the solution that you're implementing is easy for developers to pick up. It should be something that's available in the IDE so that as they're writing the code, they're able to get some suggestions, not just a scan result, but suggestions on how to fix it. And hopefully they can go out and kind of phone a friend, as we say, and just kind of ask Veracode Fix, how would I resolve this? What's the best way to resolve this? And when you do that, Veracode Fix comes back with a solution and says, here's my suggestion. Oftentimes it has several suggestions. Finally here, you want to make sure that it is going to be scalable. At any given moment on the Veracode platform, we have thousands and thousands of scans running. We've been basically cloud-based by design since 2006, and that sort of auto-scaling and elasticity has allowed us to really kind of scale things out, whether it comes to detecting flaws or providing fixes for them as well. So let's take a look at some of the numbers here. This is our flaw database, an anonymized view of the flaw database in May of 2024. And you can see for each language, we looked at which flaw types Veracode Fix can address. So Veracode Fix is aimed at specific common CWEs. And you can see here that there are several popular languages. You can see the number of flaws that AI can assist with. And you can see that it's a very large proportion of them. We try to take the lowest hanging fruit in terms of which CWEs we were going to support. And that's something we're continuing to build out in terms of language support and CWE support. But you can see we started off with the most common languages, and you can also see that Veracode Fix does apply to a vast majority, again, of the flaws that are out there. And I think this is important because if you just factor in maybe 5 minutes of time saving for each of these flaws, that could be an entire 20 years for someone to fix these. Or if you want to add more and say maybe it takes 20 minutes to fix each one of these, that could be whole centuries worth of time. The bottom line really here is that you want something that's going to help you be more productive, and it's going to help you resolve these issues and cut down on security debt very quickly. And at the same time, another sort of side benefit of Veracode Fix is, or any sort of similar solution, is really going to be that it is going to show you before it fixes it how it's looking to resolve it. So developers can actually use this as sort of a training tool, and they can better understand exactly what it was that they did wrong and understand the root cause so that the next time they can avoid that mistake to begin with, right? That's the ultimate shift left is to be able to train developers and teach them how to not introduce these flaws in the code to begin with. Yeah, this is just, again, an example based on saving 5 minutes per flaw. But in your organization, you could get a similar type of sort of chart here. We can kind of do some analysis. We can tell you roughly how many of the flaws could be fixed with Veracode Fix. It's something that you can kind of take a look at if you happen to be a customer. If you don't, that's okay too. But the point is we are able to analyze and based on the CWEs that we support in the languages. So taking a closer look at Veracode Fix itself, we have a little kind of flow diagram here. And I think what's important here is that we have a proprietary data set in the upper left. Again, this is one of the things that makes us different from some of the other AI-based security tools that are out there. Again, those other tools out there are going to be trained on code in the wild. Open source repos, a variety of other repos, whatever code they could get their hands on, that's what it's trained on. With Veracode, what we do is we take a bit of a narrower approach. And by design, we have a smaller set of data where we have examples of bad code for different CWEs, and then we have examples for how you would fix those. They're essentially patches. So we have curated data in our database. It is not trained on customer data, and that's really important. It's also not trained, again, on code in the wild. And so what happens is we have 18 years of experience at Veracode, essentially with our research team and our application consultants, our ASCs, or application consultation teams. Those are the same folks that we get on a call with you that can kind of drill into the code and provide human-based suggestions on how to resolve issues. They are the ones that go and review, along with the research team, the different patches and help to curate those and build upon those in the database. So again, it's, I think, important what data we're training it on and how we train that data. It's certainly something that kind of sets us apart in the market here. We also have, again, some supervised learning. Again, that's what I kind of talked about with the ASC team. It's the kind of helping with that and the research team. All that kind of goes into the AI remediation engine. Again, that's going to be trained on this data set. We have Veracode static analysis. That's what's actually detecting the flaws. So again, we've been doing this for 18 years. So we're able to provide an actionable set of flaws that they're going to come into your IDE. And so you'd be able to see kind of where the weaknesses sit, or kind of what type of weaknesses you have in your application. And you can trust that that this set of data is going to have very few false positives and false negatives. Again, because we've been doing this for 18 years, because we've been cloud-based and we've been able to kind of receive feedback from our customers when we do have false negatives or false positives. In any case, once you have a scan that takes place, you have a set of findings. From those findings, you can go in the IDE and just say, hey, for this finding, please give me a suggestion. Veracode Fix comes back, and it gives you a suggestion right there. And I think that's probably all there is to say about this particular slide. Over here, you can see it is a little bit of an eye chart, unfortunately. I mean, I can provide you some more details later on how you can get, I guess, some more documentation on what we're doing here, if you're interested in learning more. But in any case, what we're showing here essentially is the IDE, and we're showing the ability to obtain a fix from the IDE. So I think if I go back one here, yeah. Essentially what we have is the ability to run a scan. And you can run a scan in the IDE. You can receive the fixes there. You can also run it via CLI. So if you're not using anything that's in the IntelliJ family of IDEs, or Eclipse family of IDEs, or Visual Studio or Visual Studio Code, so something other than those, then you can use the CLI to generate these fixes. So you're not limited simply to the IDEs we support. We do support most of the common IDEs, but I think it's important. The other reason you might want to use the IDE, sorry, I should say, one of the other reasons you might want to use the CLI is to do a batch fix, which we'll talk about in a minute. This is a kind of a suggestion here that we're showing. So when you detect, or when we're able to detect an issue, we underline it here in the code, and there's going to be, oftentimes, something like this that marks what types of severity it is. If you put your mouse over this, it's going to give you some suggestions on how to fix it, some, again, generalized suggestions. And what you can do based on the generalized suggestions is you could then flip over to the Veracode Fix tab here, and you can see a sort of unified diff format that provides a suggestion on which lines to remove and which lines to add. But of course, we can automate that entire thing by simply clicking Apply Fix, and then you can compile the application and run the scan again. So this is kind of the general sort of developer experience that you'd be able to expect with Veracode Fix and Veracode in general. Again, what we have is what we call Veracode Scan. Just a quick note, I can mention that in addition to the first-party code that we're identifying here, flaws in the first-party code, we're also going to be calling out vulnerabilities in libraries. So any sort of libraries, we have a proprietary database in addition to the NVD. So we have a large set of vulnerabilities we're detecting and checking for. We also are going to be looking at licenses for those libraries. So it's a pretty comprehensive view of your application here with Veracode Scan. All right, and again, talking about batch fix, this is kind of that sort of model where you might want to run in your CI/CD pipeline, something like GitHub, you might want to run Veracode Fix and have it suggest a bunch of code changes all at one time as a PR, as a pull request. And then what you can do there is have a developer or someone who's knowledgeable with the code base to be able to go through those recommendations in the PR one at a time and accept the ones that look good or reject the ones that don't look appropriate. So I think this is sort of a different approach, but it makes it a lot more, it can really improve the efficiency depending on how you, I guess, sort of apply this and how you want to address it. But I think just the ability to tie this into CI/CD in general is really important. It doesn't have to be GitHub, by the way. We have this capability is based on a CLI, and so you can use a CLI to generate these fixes. So finally, here we have a number of available languages, and we've got again Java and Python, C#, and some of the more common ones. JavaScript; those are our top 4 languages that we scan. We've got some other ones here, Golang, PHP, Kotlin. We're adding in the rest of the languages we support now, including iOS and even very uncommon languages like COBOL. I mean, no one uses COBOL anymore, but for all the languages we support, we're going to be providing Veracode Fix capabilities. And that's going to allow you to, even if you're working on a legacy application, receive those recommendations and suggestions. So I think that's going to be important. Okay. What I think I'll do now is flip here to questions because I wanted to make sure we left a little bit of time for some questions here at the end. Does anyone have any questions on anything I discussed here? Yes?
Well, I just got done with POC for an editor review, and it was really an ineffective Golang code base. Where you guys are in the development.
I'm sorry, what was the last thing?
Where you guys in scope of being able to support Golang?
Yeah, Golang, we have full support for that now.
Okay.
We actually acquired the core technology behind Veracode Fix back in spring of 2022. So well before ChatGPT, we kind of knew this was coming. So we've been working on this for a long time. But yeah, Golang is one of the supported languages at this point. To answer your question, yeah, good question. Yeah, so that's the thing too. I mean, if you don't have some broad support for languages and CWEs, it's not an awful lot of good to have a tool. Again, not necessarily saying that tool wasn't a good one, but it is important to have the broad support across the board. And on an ongoing basis, we are adding in languages, we're adding CWEs, we're enhancing the fixes for specific CWEs that we support. So I think it's just kind of important to mention that too. Any other questions?
Yeah, on your slide that you showed about CWEs, you had C#, Java, JavaScript, Scala, Python one. Well, at the end here you showed.
Yeah, Python is one of the big ones. Yeah, definitely that is supported. We did start off with the languages that we see most often on the platform. So I'd say I think the order goes Java, C#, JavaScript, and Python in that order in terms of the most common languages that are being scanned on the platform today.
Yeah. And you mentioned you could integrate Veracode Fix in your pipelines.
That's right. into CI/CD pipelines. Yeah, so I think that's important.
What are, last question, what are some of the major companies already implementing Veracode Fix? Portfolio?
Yeah, I can tell you there are some very large healthcare and financial based companies. I can't name names, but there are some large companies out there, airlines, et cetera, that are implementing this feature already and benefiting from it. Yeah.
As you're tracking this data, I guess as code, as you track, before code is being developed 35 to 45% faster.
Right.
And vulnerabilities, or especially from Copilot at a 40% rate, are being introduced into the code base.
Right.
So as you see this happening, how quickly are you seeing that Veracode Fix is able to remediate those, or just other AI engines, like as Fix creates remediation for that, the next time that scans come through, how what's the percentage of the lower reduction of vulnerabilities, new vulnerabilities being introduced?
Yeah, it's a good question. I mean, I think there are a couple parts to it. One is reducing the security debt as quickly as possible. Like, can we sort of, again, automate the fixing of these? I mean, developers still has to review the recommendation, and they still have to make sure everything works correctly. But the idea is to save them quite a bit of time in doing so they don't have to, again, go out and Google and trial and error. They're going to have some suggestions. Usually there's 2 or 3 suggestions, at least. Sometimes there's 5 that we offer. So depending on your coding style, you can pick one or the other. But the idea is really to kind of apply those fixes and reduce the tech debt quickly, but at the same time, train developers. So I think that is one of the benefits there, is that as developers are continuing to write their code and review code that is generated from AI type of tools, that they're going to be able to spot places where this doesn't look quite right. So they're going to be able to go in there and identify that. And I think that learning aspect is important to preventing future flaws from being introduced into the code base.
And then I guess the next part is, how often are the ASCs kind of going back and training the Veracode Fix engine as well?
Frequently, very frequently, yes. That's part of their job description now, is to go in and review those patches that we're training our model on, and making sure that they are appropriate, they have the right fixes, they have the proper, again, good examples of bad code, and making sure that for a given CWE, they're able to cover all the bases. So we're constantly enhancing that. It's an important task that we're working on.
This last one here, this
Yeah.
might be, I can get you afterwards.
Oh, yeah, no,
Just
yeah.
trying to think about, we use Veracode, right now, but not the Fix product, but.
Yeah.
How do you protect the customer's data? You're scanning by application code.
Right.
You want to be nosy,
No, that's a great question. Ultimately, again, Veracode has been cloud-based, and thank you all for joining, by the way. I guess we can sort of officially end it here, and I'll answer your question, though. Veracode has been cloud-based, again, since 2006. So that's given us a tremendous amount of time to not just build out the functionality and the scalability, but the security for the platform. And so we have all types of accreditations, SOC 2, et cetera, all types of attestations for the platform itself. Code is always encrypted in transit and at rest. It's really important. And when we get the code in order that comes along with basically our scan results, we're going to generate a suggestion based on the AI and the generative AI. It's going to come back with something, but your code is thrown away at that point immediately. The only reason we needed it was to generate that particular recommendation. So we're going to be throwing it away right away. But any code that you do upload as part of an analysis is going to be protected using our I guess, normal kind of expected feature set in terms of a secure cloud environment. So,
You don't ask the manager's question, so.
yeah, I understand we're over. Yeah, thank you all again, all for your time. Appreciate it. Thank you.